Hello and welcome. What we have here is example 5.28, where there is an annuity of infrequent payment. So we have Alex born, they receive an annuity of $450 payable once every 2 years. The annuity stretches out over 20 years. The first payment occurs at date 2, that is 2 years from today, and we're given an annual interest rate of 6%. I'm going to approach this the same way I've been approaching all of the problems, which is first structuring it as a timeline and basically ignoring our present value of an annuity formula. However, I am going to solve this with this formula later on in this video. First, I'm going to put it on a timeline. So here I'll have time as my first row, and I think it was 20 years. So I'm just going to create a 20-year timeline. There we go. And center and bold my timeline. So we have it. It's an annuity, which means it's an equal payment. The first payment occurs at time period 2 and every 2 years. So 450. I'll just manually type this all the way along, or maybe I'll copy paste. There we go. We have a discount rate of 6%. And what I'm going to do is just my very fancy formula, the present value of the cash flow. So I'm going to use the present value of a single amount formula, which is my future value, divided by 1 plus the discount rate to the power of 2. And this is the present value of 450 discounted at 6% 2 years from now. All right, so I can just kind of copy and paste this all the way across on the even years until period 20. Now to answer this problem, what is the present value of this? I sum up my individual PV amounts, and I get a present value of 2505.57. So this is the answer here. This is timeline, the timeline approach, which is generally my preferred approach, at least from a teaching perspective. All right, so now what we can do is essentially convert like this into an annuity such that we're going to assume 10 annual payments. In order to do that, though, I'm going to just double click on this cell. If I look at my denominator here, I have to the power of 2 in my denominator. Let me just copy and paste this, just my denominator only. And down here, if I press equals and paste, I have 1.1236. This is essentially the 2-year equivalent interest rate over 2 years, because 6% will compound. So it's going to be high. It's not 6 plus 6% over 2 years. It's going to be slightly higher than 12% because of the impact of compounding. So it's going to be basically 12.36% is the 2-year interest rate. So now what I can do is basically put that into my formula. So my C here, my cash flow is 450. Oops. Redo. And I'll have 1 divided by R. So here I'll do 1 divided by 0.1236. And here what I'm going to do is 1 divided by R times 1 plus R to the power of T. So I'm going to do my denominator first, which is going to be just 0.1236 times 1.1236 to the power of 10, right? 20 years, every 2 years, 10 years. And I get this, but I need to put this all underneath 1. So 1 divided by that. And this is 1 divided by R, 1 plus R to the power of T. Okay. So now what I have is, let me see, I have my cash flow, and I'm going to multiply that by this, subtract this, and hopefully I get the same answer, and I see that I do. Okay, so the trick to this one was just converting, if the payments are more than less than once per year, I mean, we need to convert the rate into its annual equivalent rate, which we can obtain basically just from the first payment here. All right, I hope you found this useful. Maybe what I'll do is put a border around this one to separate it out so we can see. All right, thank you very much. If you have any questions, please feel free to reach out. Take care, everyone.